in the air pressure lesson, a warm, moist air mass is going to rise, while a cool, dry air mass is going to sink. The rising and sinking of air causes changes in air pressure. The warm, moist air mass that moves up creates what we call an updraft. Since it's lifting up and off the ground, this is low pressure. Versus the cool, dry air mass has a downdraft and is pushing air down, and this is what we call high pressure. However, the movement of air begs the question of what goes in the place where the air used to occupy. We obviously can't have a vacuum there, so something has to go in its place. Warm, moist air cannot rise unchecked. Rather, it will rise to a point in the atmosphere that is called the tropopause. This acts as a boundary. When the air mass hits the tropopause, it cannot go past it, so it begins to flatten out and spread out. As it spreads out, it rushes to fill in the space that was once occupied by the cool, dry air mass. Conversely, when the cool, dry air mass reaches the ground, it will also spread out, and it will rush into the space that was once occupied by the warm, moist air mass. This movement of air is called wind. The cold, dry air moving across the surface is called surface winds, while the warm, moist air moving across the upper atmosphere is called upper winds. If you recall, air is heated from the ground up. That means that the cool, dry air that moves along the surface will eventually be heated through the process of conduction when the heat in the ground gets transferred to the air particles above the ground. As you know, this warm rising air is called an updraft now. Conversely, the warm moist air rises in altitude and is further away from the heat in the ground. Therefore, it's going to start cooling down and sink down, creating a downdraft. This cycling of heat in the air is known as convection. This process repeats itself, and this is how we have surface winds and upper winds. Also, the greater the difference between the two air masses and temperatures may also cause stronger updrafts or downdrafts in a particular geographic area.
Let's take a walk around to the front of the building and see how we can apply what Mrs. Ostrowski has just taught you. If I look up at the flagpole and see the surface winds blowing the flag to the right, but I follow the clouds in the background and they're traveling to the left, that tells me that the surface winds are going in the opposite direction of the upper winds. That means we have a conflict between some warm, moist air rising and moving across the upper winds and cold, dry air sinking. This is a frontal system, a boundary between warm, moist air and cold, dry air. This is where storms form. If my flag is pointing in the opposite direction the clouds are moving, I know that a storm is coming soon, and I need to take shelter. On the other hand, if the flag is flying in the same direction as the upper winds are carrying the clouds, this is a stable system. I can expect weather to be nice for at least several hours without changing. We also can use wind to tell us something by looking at the direction it's coming from. Low pressure systems always circulate in a counterclockwise manner, while high pressure systems always circulate clockwise. That means that if I look at the winds between those two systems and I stand with my back to the wind, the high will always be on my right hand side. If I stand with my back to the wind, the high is on the right. Since weather systems tend to move from the west to the east, if my right hand side is facing the west, then I know that the weather will be improving as the high pressure system approaches. On the other hand, if I find myself facing north, the high is on my right in the east and is leaving me. The low will be approaching soon and the weather will be deteriorating. It's time to go inside.